It is very late at night tonight and I fell down an internet rabbit hole as you do, and I was reading up on a topic that I found most interesting. I am massively obsessed with nuclear physics, anything to do with nuclear, disasters, reactors. I find the way they're built and the way that they function really interesting, and I was learning about something called the Demon Core, and I thought this would be a really nice video for us to sit down and go through. I'm going to be telling you a story of a core of plutonium that killed 2 people over a few-year period. And it's kind of creepy, like in a non-science way. It's kind of creepy how the whole thing pans out, but from a science perspective it's also very, very interesting, the mechanisms of how this happened. These accidents happened in 1945 and 1946, so it was around the World War II time, and this is when the US was experimenting with nuclear bombs. I believe the intention was to use these bombs on Japan. Meanwhile, whilst this was happening, Japan was engaging in some very, very brutal isn't even the word for the kind of experiments and the kind of weapons they were using. It was really bad. But the US was working on their own thing, and they were backed by the Canadians and the UK in doing this. It was a joint project. The Demon Core was a 6.2 kilogram core of plutonium. In this instance, it was being used obviously for the testing and development of bombs. Also, I wanted to do a science video and an ASMR video, so I kind of mixed them together, so I do hope that that's okay. So before we go into the story, it's going to be much easier for you to understand the topic if I give you a very quick introduction into nuclear physics. So I'm going to keep this super, super short, sweet and simple, but this is just like a basic intro, so the rest of it will make perfect sense. So to be able to explain this well, if we quickly cover what an atom is, an atom basically has a core that contains neutrons and protons. So one of those has a positive charge, one of those is neutral, and around the outside you have these electrons that orbit it. So it's kind of like the Earth and the Moon. The core is like the Earth and the Moon is like the electron. So plutonium and uranium are probably the 2 nuclear fuels that you might have heard about, and they're quite big atoms. Their atomic mass is 239. So water, for example's atomic mass per molecule is around 18. It's 16 from the oxygen and then 2 hydrogens which have 1 each. So I know this probably isn't going to make too much sense if you're not into chemistry and stuff, but the basic thing to remember is that it's a very big molecule. All the different elements that we know of have different nucleuses, and then obviously they have different electrons on the outside to balance the nucleus with that charge as well. But the main thing to remember here is that plutonium and uranium are atoms just like oxygen and hydrogen, all the ones that you've already heard of. They just behave a bit differently and they have a different use for us when we utilize them commercially. So the nuclear reaction is begun by an initial bombardment of neutrons. So you might remember neutrons are the things that are already present inside the core of the atom in the nucleus, and what you're doing is you're taking a bunch of those neutrons by themselves and throwing them at atoms of plutonium or uranium. But in this example we're going to stick to plutonium because that's what the story is about. As you can see on my beautiful hand illustrated diagram here, this shows the full reaction. So you have a big molecule being split into smaller pieces using those initial neutrons, and when that happens more neutrons get released and it can actually create a sustainable reaction, which is what we see in nuclear fission, which is when we use it in nuclear power plants. The neutrons aren't released instantly when the molecules split, but you don't need to worry too much about this for now. So the first man to die as a result of this core was Harry Dalian. He was an American physicist working on the Manhattan Project, which is the project in which they were developing their nuclear weapons. Now he accidentally irradiated himself whilst he was experimenting with the plutonium core. This is obviously, I mean, when I tell you this, we're talking about radiation. Obviously this was 70 years ago, 80 years ago, but this man dropped a tungsten carbide brick onto the radioactive plutonium core. It's not just plutonium, by the way, it's plutonium gallium, if that means anything to you, but I just say plutonium is much easier. The reason he was playing with these tungsten carbide bricks was he was actually building them around the plutonium core, and the idea of this was the mass of the plutonium core was subcritical, which means by itself it's not enough to maintain a continuous stable nuclear reaction. But by using these bricks around it, it pushes the neutrons that are being forced outwards back inwards into the core, because in the core that's what's happening. It's these neutrons being fired around, and it's like a chain reaction, but it wasn't enough by itself to continuously keep itself going, which is what they needed for a nuclear bomb. And so by stacking these tungsten carbide bricks around, it would decrease the mass needed to go supercritical. Now he did have a neutron counter there with him, and as he was placing the final brick on this mini wall, he got an alert with the counter letting him know that if he was to place that final brick, it will go supercritical, which is obviously not ideal. Everyone would become irradiated. You would get neutrons being fired out everywhere, right? So obviously they're trying to experiment with these things, but you don't really want a nuclear reaction happening like right in front of you with no protection. So he was withdrawing his hand and the brick right? But you can imagine you're a bit panicked. It's like you're already about to place it. You're already nearly in that moment, right? And this is 1945, World War II. And as he was pulling his hand back, that was when he dropped the brick right onto the plutonium core. It caused it to temporarily become supercritical, which forced out a massive wave of neutrons, which ultimately led to him becoming irradiated and dying 25 days later. Obviously, you have nuclear bombs, bad, and then you have like nuclear reactors, which in a general sense, when they're being managed well, are good in terms of efficiency and stuff like that. Naturally, it will want to grow exponentially, so it has to be managed well, and when it's not managed well, you have things happening like Chernobyl, which we're all very aware of, and things just grew exponentially to the point where they couldn't manage the reaction anymore and ended up causing a massive explosion, which even to this day is still highly irradiated. If you want to look into that, just search for the elephant's foot. There's a photograph of the actual the core that melted. It's crazy. It's really creepy. Now, in order to halt the reaction, because obviously he's already built this tungsten carbide brick wall around it, so by this point that extra brick being in contact with it has caused the reaction to start, he had to disassemble that brick wall. So he's already been exposed to all this radiation from the initial supercritical moment that this has occurred when he's dropped the brick, right? Fully aware of that happening, he then still has to dismantle this brick wall, because if he doesn't, it's just going to continue, which is obviously just highly deadly. And bear in mind, there are other scientists in the room as well at risk. Now, despite this happening, us humans still did not feel the need to develop equipment to handle these sorts of processes for us. This process continued to occur in terms of people physically lifting. With the next reaction, we'll get into it, but this whole manual process of handling plutonium and stuff like that, now it's not done like that. But back then, we were just like, woohoo, you know? Around 1 year later, another American physicist called Slaton actually died from the exact same core, which is when it originally got its nickname, the Demon Core. Now, his death is also very, very interesting, and it was slightly different the way that it occurred, and there were other people involved as well, but he actually was able to note down like the experiences that he felt when this happened, and when we've had similar nuclear events happen in history since then. For example, in Japan, other people that were there have noted experiencing the same sort of sensations, and one of them is really interesting, and I've researched this quite deep into the physics side of it, so I'm going to give you some information about that. So Slaton was working with 7 scientists around him, and his experiment was slightly different. So Louis was working on the same Demon Core, which was a subcritical mass piece of plutonium, so by itself it was not able, without help from other compounds and neutron reflectors, to maintain a stable reaction. He was placing this inside 2 beryllium hemispheres. So if you imagine you have a sphere chopped in half, and then in the middle of that there's sort of a gap. Inside there is where you are putting the plutonium core, and then on top of that, that's where you're putting the other beryllium hemisphere, and it's making a neutron reflector around the core. So the same sort of principle, instead of using the tungsten carbide bricks, now it's beryllium instead to reflect the neutrons back into the core. From the sound of things, when I've been reading through literature, the way that he was performing this experiment just wasn't really safe. Like, he wasn't following usual protocol, and around 20 years later, someone that was present in the room actually spoke out, because he was being praised for his work in helping the other people in the room survive. But someone actually spoke out and said, no, like, he wasn't following safety protocol, and that's why this happened in the first place. When you're lifting this hemisphere, you're supposed to have it wedged on one side up, because you can use your hand to lift it, but obviously if you were to drop it, it could initiate a reaction really easily, right? So you're supposed to have one side propped up, so even if you happen to drop one corner of it, you're still not putting it completely around the plutonium core. And so, for example, here's a photograph of like a reenactment of what should have been happening, but in the room, this is not what was happening. He removed that piece, that safety piece. Instead, he was just holding that top hemisphere of beryllium in his hand, and he was wedging it up with a screwdriver. Okay, so you literally have like a very, very dangerous plutonium core that already killed someone a year earlier, and he's wedging up his hemisphere with a screwdriver. Okay, even a door wedge would probably have been safer. Do you know what? Honestly, it's just crazy, the safety back then. Around 3:20 p.m, whilst he was doing that experiment with 7 other people in the room, the screwdriver slipped, and the entire hemisphere fell on top of the plutonium core, meaning that it was a core completely surrounded by this neutron reflector. This again caused the same type of prompt critical reaction. So when we were speaking earlier about the nuclear reactors and how they do like a long-term reaction dependent on like the slow release of the neutrons, when the fission occurs and that big atom splits into 2 smaller atoms, usually there is a delay for that neutron to be released when you're doing it in like a nuclear reaction for energy. But when you're doing a nuclear bomb, you're creating a prompt critical reaction, which is like you're not relying on the long-term degradation, and you're relying on that instant burst of neutrons, which is incredibly dangerous. That instant burst of neutrons, we called ionizing radiation. It has the ability to rip an electron off an atom, ripping one of the smallest things we know of from those things. I mean, it's absolutely insane. The science is crazy. You think quarantine is bad? Subcritical going supercritical? Even worse. So at the time this happened, all the scientists in the room felt two things. The first thing was a heat wave. Now, people actually believe that that sensation of heat wasn't caused by physical heat, but instead the actual neutrons activating the heat sensors in the skin. So there wasn't actually any heat released, but the sensors were activated by the radiation. The second thing was a blue glow. Now, this is super, super interesting. People were originally thinking like, oh, what could be causing this blue glow? Like, it must be light coming from the reaction. Originally, people did think it was something called Cherenkov radiation, which is the kind of blue glow that you get around a reactor. And this blue glow is produced by a very, very strange thing in physics, and it's kind of hard for me to describe without going into like mega physicsy terms. In physics, if something is moving at a higher speed than light, then it leaves a blue trail because the ionization is moving through a medium like the water, for example, in this cooling thing that you can see. It creates this blue glow, and people thought it was the same thing that caused the blue glow that these men saw when the reaction took place. But in fact, it looks like it was something completely different now that we believe it's actually the air being ionized. And so that's one of the crazy things. Like, imagine this thing drops and suddenly you feel this massive sweep of heat through you. You see this blue flash in your eyes, and that's it. You have like a potentially lethal dosage of radiation. That's literally all you needed. Absolutely crazy. Nuclear is mad. The Chernobyl disaster, for example, I would do an entire 3-part series on that. It's so interesting. My dream one day is to go and visit the actual reactors, the other ones that are still in one piece, but even the one that blew up, I would love to go and see it. I just find that kind of thing so interesting. Just so interesting. Just man-made structures and massive disasters. So this prompt critical moment was obviously just a brief moment where it went super critical, right? Where the neutron reaction was sustainable and it was growing exponentially, and he was later praised after his death for removing the beryllium hemisphere from the top because it obviously halted the reaction. So people were like, oh my god, he saved the lives of everyone else in that room and all the people in the building that could have obviously, you know, sustained radiation injuries because he halted the reaction, whereas he could have just run away and, you know, not bothered to remove the top piece. But yeah, I don't know, I don't really feel like, I feel like common sense would be, oops, I've accidentally started a nuclear reaction, I should probably stop that. Do you know, do you know what I mean? So I thought that one was a little bit strange. Now, Slaton actually reported that he also experienced a sour taste in his mouth. So this whole thing is very interesting. Like, I'm just imagining in the future, for example, this is very dark, but if there ever was a nuclear war, for example, if we saw, you know, a flash of blue light and then a heat wave come across us, like obviously if you're very close to the reaction, it's going to be a big heat wave, right? It's going to rip you to pieces. But if you were far away and then you experience the sour taste, you would like almost be aware that like you've potentially just received a fatal dosage of radiation. And that for me is just crazy. Like, it's just so strange, because think about it, when you see fire, you know you're going to get burned, right? And when you see water, you know you're going to get wet. And when you see ice, you know it's going to be cold. But nuclear, you don't really see it. You just see a stone, right? A block of plutonium and something that is reflecting something that your eyes can't even see, the neutrons, back towards the plutonium. And so that for us humans, it's so strange because we don't have the senses that we would need to even really identify and detect this reaction happening. And it's really only through like post-process methods that you realize something has happened. And one of the people in the room actually developed like a long-term issue with his eyesight along with neurological disorders. Everyone in the room had some sort of issue and died within 20 to 30 years of things that are related to radiation, but all different things at the same time. So it could have been chance or it could have been to do with the reaction, but probably most likely to do with the reaction. Whilst this was happening, I believe it's called a dosimetry badge. I might have pronounced that wrong. They're used to detect radiation, at least they were back then. Now we've come a little bit further in terms of what we can detect and stuff like that. But they were being used at the time. But again, it just safety precautions not in place. They were supposed to wear them at all times because I'm sure they can track the highest level at any given point. So if there is like a critical event, they can see how much radiation they've been exposed to. None of them were wearing badges. They were locked 100 feet away in a chest of drawers, so they had to go and get them. Alongside this, these dosimetry badges were supposed to be mounted underneath every desk for the same reason, to be able to detect if anything happens, just to be able to go and check the values, right? And they weren't there. So people really didn't know how much radiation they'd been exposed to. Slaton ordered everyone to go and get the badges and place them around the room, but everyone thought he was just, you know, his mind was going a little bit given what had just happened because the radiation's already swept through the room. So you might pick up the reminiscence, but it's not really going to tell you the dosage that everyone has actually received. You would need to have a badge there measuring that as it happened. It's like a wave, like a sea wave, right? Or like a gust of wind. So this whole thing happened on the 21st of May 1946. By the 30th of May, he was dead from radiation poisoning. Obviously, they left the building, evacuated, and the first thing they did when he got out of the building was vomited. This is a very common reaction for people that have received a high dosage of radiation. Now, Slaton was very supported during this time because obviously he was considered to be doing good work. Obviously, developing the nuclear program, it was a defense mechanism or some way to end the war, however you want to justify it. A lot of people volunteered to donate blood to try and help. It was a loss, and his life was very celebrated. And it was spoken about throughout literature for years to come afterwards as well. In terms of his actual death, I know this is a bit dark, but just to go through the symptoms of like how it progressed. So we have red skin, swollen hands, inability to really pass urine, severe diarrhea, intestinal paralysis, blisters, and gangrene, which is obviously just very, very horrible. I mean, you have to imagine a lethal dosage of ionizing radiation. Literally, the electrons are being ripped off the atoms in your body. I mean, it's like, that's next level weaponry. That's just like Geneva Convention, thank you, like just very bad. One of the doctors at the time described it as 3D sunburn inside the body because of obviously like the radiation from the sun. Only 7 days after the event, he was already losing his mind. So he was very confused. He wasn't too sure what was happening. His mother and his sister were both flown in, and they spent all of his last days with him. The way that it was described in literature was a total disintegration of bodily functions by the end of it. Because I guess every single cell in your body is basically dying slowly, right? And your DNA is completely destroyed. And it's not so much that the initial dosage completely destroys everything, but it destroys enough to cause the person to die, if that makes sense. It's like enough poison. But yeah, he slipped into a coma and died on May 30th, and then he was buried on June 2nd. I mean, this is like a long time period. People present at Chernobyl were like dead within minutes, right? So for example, the elephant's foot, just to reference this, like I get very excited about this, but the elephant's foot, which was the melted component of the actual reactor which had just seeped through into a room underneath, it was very, very crazy. People that actually saw that were dead. Like if you saw the elephant foot at that time, you were as good as dead, because the amount of radiation you will have got from being in the same room as it, like you have minutes to live. So there were firefighters, for example, that I think went in at Chernobyl and tried to put water on it to cool it down and stuff like that, all dead. I believe that 30 or 40 years later, it has actually cooled down quite a lot radiation wise. I still don't think it's safe, but I do believe it's much, much safer than it used to be. But obviously it's still very dangerous. It's like a molten nuclear core. For anyone wondering, Russia didn't stop using those nuclear reactors. They made lots of them and they continue to use them. And even to this day, I believe that some of them are still in commission, the exact same design. They put some safety precautions in place where I think they put lead, a big thick piece of lead or some sort of alloy underneath the reactor, so if it did happen to melt, it wouldn't go through to the ground and contaminate like supplies, like water supplies, obviously, because if that was to happen, it would just be detrimental to like the entire area nearby. Even the other reactors continue to be used. There was 4 reactors at Chernobyl, and just because I think, was it reactor 3 or 4? I think it was reactor 4 that blew up. The other ones were still in use, at least one of them was still in use, and there was a fire at one of the other reactors years later. So it's like, really? There was an army guard present, and this is also quite like a strange story. He was present at the time as well. Afterwards, he rejoined the army and he was promoted to a very, very senior level. And within 4 years of the reaction, so obviously it's 1946 that it originally happened, he died in 1950 in North Korea in the war. So this man that managed to survive this nuclear reaction literally just died 4 years later. And he was young. I think he was 24 when this happened, or 25? I think he was 24. So now the weird thing is that for people not really like doing nuclear science full time and studying it like I don't, I wouldn't have imagined the core would be like destroyed, but you kind of imagine it would be decommissioned potentially. But then again, it's like, no, because there's not a problem with the core, there's an issue with the people that were handling it in the most respectful way possible, right? It was human error that caused the issues, just like with Chernobyl. They ended up not using the core for the 3rd experiment that it was due to be used in. So there was already 2 after these 2 people have died. Project Charlie, it was supposed to be used in, because they'd used it underwater alongside the high levels of radioactivity, which they hadn't expected. They've been unable to decontaminate the ships that were affected from the radioactivity. So I think they realized at that point, like, maybe we're getting a bit ahead of ourselves with this nuclear stuff, right? Just because we can do it doesn't necessarily mean we should. Now, obviously, after the second death, they finally invented a machine to do this for them, and this is called the Godiva, which was then succeeded by the Godiva 2 or Mark II. And these were just very, very basic machines that could lift and take things away and from the plutonium core. So that obviously makes things a lot safer. You don't have a person just stood over a nuclear core, like lifting it with a screwdriver. I mean, just ridiculous, right? Nuclear is very, very interesting, and I do think nuclear is the future. Nuclear isn't the issue, humans are the issues, like our inability to just be patient and do things properly long term, and our corporate greed and our egos, Chernobyl, like there's just so many issues with how we behave as a race in general. Obviously I love humanity, but there's if you go back through history within the past 100 years, just the past 100 years, which is not a long period, if you look at some of the stuff that's happened, like if I was an alien flying past this planet, I would not stop by, right? Like honestly, World War II, some of the stuff, like, oh. So anyway, past that point, they just melted down the core and reused it. So even today, to this day, reminiscence of that core that killed these two men in these tragic accidents is still present and still being used in various different nuclear experiments. Now, one of the reasons I'm so interested in nuclear is I'm very, very interested in space travel and astrophysics and anything to do with that. And I truly believe there is so much potential to use nuclear in space. And I think the only reason we're not doing it is because to use nuclear generally is very frowned upon, obviously for good reason. We've all seen what happens when people start pointing nuclear missiles at each other and the Cuban Missile Crisis and stuff like that. It's just, that's one of the things that I'm just very interested in. And you know what, actually prior to all of this, like a long time ago, they were actually experimenting with space travel with a special type of engine that used nuclear pulses from a nuclear reactor, which is obviously very interesting. And I believe that in Kerbal Space Program 2, which is hopefully coming out very soon, it's like a space simulation game. Amazing, literally one of my favorite games ever. I play it like, I put like 800 hours on that game in like 2 months. It's really bad. Apparently they actually have a prototype for that engine, which is super interesting. Alongside this, speaking of nuclear reactors in space, I came across this ages ago and I can't remember the specific. I believe it was launched in 1963 and the Americans built this small nuclear reactor and launched it into space to sort of test a theory, and it was launched into space. It was a fully functioning nuclear reactor, just a proof of concept, and it wasn't the nuclear reactor that failed, it was the electronics on the actual spaceship that failed. That caused it to just be a loss, right? And it's predicted that that's going to be circling around the Earth for another 3,000 years, which is obviously crazy, and I believe at the end of that 3,000 years it should be degrading and burning up through the atmosphere. I just found it super interesting. Apparently scientists have been looking at the skies and they've seen that it's actually been shedding. So when I say shedding, it means like part of the actual spacecraft have been like breaking off, which they think means something has hit it at some point. So it's obviously a little bit concerning because space can get quite crowded and all it takes is one thing to go off course and hit something else that hits something else, and then you have a ton of satellites getting destroyed and a ton of space waste flying around the Earth. It's very difficult to get rid of. That spacecraft, for me, I hope that in the future of the human race, I hope that we have the technology to launch a ship that goes and looks at that reactor and goes to see what happened, right? It could be something so minor that caused it to break with the electronics, but for me there's something so eerie about a fully fledged, fully functional nuclear reactor just floating in space but not running, waiting for its inevitable death. I just find it so there's just something eerie about it that I'm very interested in, especially the photos of it as well, if you go look at the photos. But yeah, I'm really interested to hear what you think. This is like my 3rd or 4th science video in 3 or 4 years, and I really love filming them. I really enjoy them, but I like to do them when I find something that really inspires me, as opposed to like doing it on a schedule or something like that. Let me know what you think. I really hope you enjoyed the video. If you want to see me outside of YouTube, I do have an Instagram down below and other various things, but Instagram is really the only one that I use. I read all the comments, so if you enjoy the video, you can write to me and I will 100% read it. If not now when I post the video, but at least in a few weeks or a few months I will come back and check them. So yeah, I really hope you enjoyed the video. Thank you for watching and I will see you very soon. I love filming this. It was so much fun. I want to do this more often. This is a great way to spend like a very late night / early morning. I really enjoyed this. So thank you for spending it with me. Thank you. Bye.